After having covered everything around Azure networking, it's a good time to move on with virtual machines, which is another core component in the Azure infrastructure services. Where this first section is around designing solutions using Azure virtual machines. Where I'm going to start about the virtual machine building blocks, like what are the different Azure resources, individual resources that you need for building Azure VMs, highlighting the different virtual machine sizes, talking about high availability of Azure VMs, and describing the underlying virtual machine storage architecture. So deploying Azure virtual machines, literally building infrastructure as a service. The different building blocks for having a full functional virtual machine in Azure is the virtual machine size or the compute unit, an underlying storage resource, and a networking resource. The networking resource is covered in the previous section, where the virtual machine sizes also requires a little bit of explanation. Azure for now gives about 70, maybe 75 different virtual machine sizes. So it's a full list of alphabetical virtual machine nominations, where in the end it's not always that important to pinpoint a specific virtual machine size for a specific workload. Although Microsoft is trying to guide you in a certain direction, like using a certain virtual machine family, and overall the high-level view is general purpose. So this could be like about any server, web server, domain controller, maybe file server, but not really having a lot of storage, a small database server, so valid for about any typical workload. Compute optimized gives you better CPU performance. Memory optimized, obviously better memory performance compared to storage and CPU. Storage optimized is lower in CPU and memory, but giving you a larger amount of storage. The N series, which is equipped with graphical processing units, so mainly targeted towards multimedia or 3D alike workloads. And high performance is obviously the opposite, giving you a lot of performance on all characteristics of the VM, mainly used in high performance compute. For each and every of the family types, there are a couple of different flavors depending on the age of the data center, depending on the location. So it's mainly pinpointing that you can choose from a full set of different VM sizes, where each VM size gives you CPU, memory, and storage capacity, where you cannot change those configuration settings. If you need to make any changes to the characteristics, the only option would be migrating or changing with another virtual machine size, but keep in mind that this action involves downtime for the virtual machine. So the general purpose is a nice balanced machine having a balanced CPU to memory ratio, typically used in testing, development, small to medium database servers, and maybe low to medium traffic. And in meantime, the latest version of the general purpose, the D version 3, also supports Hyper-V nesting, which means that you deploy an Azure VM, install the Hyper-V server role, and within this Azure VM, you can deploy additional Hyper-V VMs as well. For the compute, it's a bit easier. The F series, giving you high CPU to memory ratio, typically used for traffic routing web servers, network appliances, or overall generic application servers. The memory optimized, typically used for database servers if you want in combination with caching solutions, and also the latest ones in D series, the EV3 and the M series, are supporting nested Hyper-V. Storage optimized is the LS series, where you get a high disk throughput and quite performing IOPS for the underlying disk subsystem. Typical use scenario, big data like tooling, SQL Server, maybe larger MySQL or non-SQL based databases. And then the N series, as I already mentioned during the introduction of the different VM families, N series are equipped with specific NVIDIA chipset, so specifically targeted for heavy graphic video rendering, video editing, building 3D animation, doing complex AutoCAD drawing, for example, could be another one. Then a specific group of VMs, the H series or the A8, 9, 10, and 11, are known for high performance compute processing, giving you the fastest, most powerful CPU virtual machine with optional high throughput network interfaces, or also known as RDMA. So mainly used for powerful machines. And then the SAP HANA is also a specific one where it's really about a purpose built for that workload. And it takes a couple of weeks before they're actually available in an Azure data center because it's deployed on physical servers with large amounts of memory. As a first demo, walking you through the deployment of a virtual machine using the portal, where in short the steps is defining a name, local logon, username, password, selecting the network that you want to link to the virtual machine, and technically waiting a few minutes before the virtual machine is actually deployed successfully. So this could be PVM1. I need to provide the username and password, where I also need to follow the complexity requirements from the given operating system, linking it to my subscription and a resource group. Let's take the PRG and my allocation. So the first part of the validation is done, and it moves up to the sizing, where for typical training demo scenarios, I mainly deploy the DS1 V1 or V2. So checking if that flavor is also available here. Looks like it. Next, selecting your network settings. So I'm going to keep all my defaults for now. If you missed the first part where I'm talking about networking, then obviously might be a good refresh of your existing knowledge or experiences. And lastly, creating your configuration item and the deployment kicks off. Now, obviously in basic environment or like dev and test or SMB-like scenarios, it's like the typical customer is still using the portal there. Now, in a larger environment where you have a lot of automation already in on-prem, using automated provisioning and gradually expanding to the cloud, then you can use any of the two command line interfaces, being Azure PowerShell or the Azure CLI tool that you install on your Windows client, Mac, or Linux. Or instead of installing the client, you could also connect to a Cloud Shell directly from within your Azure portal in the browser. And ultimately, for repeatable deployments, for more complicated deployments, you can also use a concept that's called Azure Resource Manager templates, in the industry known as infrastructure as code, where you're going to translate all the characteristics of the building blocks of the virtual machine configuration in an ARM template and reusing the template whenever it's required. And showing you in PowerShell. Why PowerShell? Since for sysadmin operations teams, they already have PowerShell experience, depending a bit on complexity. If you already have PowerShell experience, then you can just reuse it. So what I have in my environment here is a PowerShell script that I actually built to speed up the demo a little bit and walking you through some of the configuration options. So the first thing you have to do is authenticating. So as you noticed already in former demos, when I'm connecting to the Azure portal, the first thing I need to do is authenticating. It's the exact same thing in your PowerShell session. Then, depending a bit on the use case, if you have multiple Azure subscriptions to manage, you can do a get Azure RM subscription, which will list all your subscriptions. And next, select Azure RM subscription, where you point to the subscription name and allocating that one as the default for this specific PowerShell session. If you close your PowerShell session, then obviously you have to go through step 1, 2, and 3 again. Then another check you can do is if you're actually in the correct resource group by reading out all of them using the commandlet get Azure RM resource group. And from here, we're going to start building. What I can do is already executing part of the file. And with the login Azure RM account, it's asking me for my credentials. Pretty similar to the portal behavior, only the pop-up is sometimes a little bit difficult to read. But besides that, it's actually doing what it needs to do, recognizing your username, password, MFA if you want, and showing a list of Azure resources. So it's running and it's reading out my resource groups. Still loading some additional subscriptions that I'm having. I think we're almost there. And the output window, it's showing you the default subscription. And once all the subscriptions are there, I'm going to define that the one subscription becomes the default. Reading out, creating the new resource group, and we're ready for the next step. So in the meantime, I was updating my PowerShell script here. So what I'm going to do is creating a new Azure RM resource group that I'm going to name the Packed PowerShell resource group in West Europe. Next to that, I define some variables where this is the Packed PowerShell resource group, Western Europe, and the virtual machine name. Since I need to deploy the VM and I don't want to store my password in clear text in my PowerShell script, I can use a solution called Get Credential that will provide you a pop-up in which you define the local admin username and password for the VM that we are deploying. Then we're going to create a subnet, a virtual network, public IP address, an inbound security group rule, the network security group itself, integrating with a virtual network card, associating the public IP and NSG, and lastly, creating the actual virtual machine. So just verifying if everything is covered. Sometimes it's about some details and names that I'm using. So this could be making it a little bit shorter. Packed PowerShell rule. Security group, everything looks good from here. So everything else from here all the way down and running it. So this is the Get Credential. So this would be my local admin user that I'm going to use for this specific virtual machine. And deployment, if all goes fine, is kicking off. There we go. So this one is running for some time, depending a bit on complexity of the machine, but that's really what it takes to deploy it using PowerShell. At the same time, my resource group should already be available piece by piece. So the subnet is there. Let's try doing 2 at a time. And everything else from here is running. Public IP looks pretty good. Subnet is there, virtual network, public IP. So we're going to give it a little bit more time. But if I check back in my portal, refreshing, there should be the Packed PowerShell resource group and already having some resources in there. So I'll keep this running for now and moving on with the next part, which is another mechanism. It's using an Azure Resource Manager template. We're going to cover Azure Resource Manager templates and infrastructure as code, or DevOps even if you want, in another section. But a good resource to start from is Azure Quick Start Templates. So there's a public repo on GitHub, Azure Quick Start Templates, that allows you to deploy about any Azure resource or even a collection of resources like 5 VMs, 2 network, VNets, configuring backup, site recovery. That's all covered out of an ARM template. Now the ARM template, again, it's provided as a community item, so there's no formal support. You cannot complain about it. Well, maybe you can, but not gonna get any compensation. And what it gives you is a deployment file that's based on a JSON file structure. So what you can do from here is copying this from GitHub, and this time from the portal or CLI or PowerShell, you can run template deployment here in the portal, pasting in your JSON file structure, or if you even want, uploading the file and building your own template. When I'm saving all those settings, it's pretty similar to deploying a standalone VM, but this time we're using ARM template, where the more information you type in the template file, the less fields obviously the user has to complete. Confirming, there's another last step here. You actually need to confirm that you're okay with the deployment. What else did I miss? And again, deployment is rolling. Another interesting feature that Azure IaaS VMs is giving you is virtual machine extensions. A virtual machine extension allows like a post-deployment configuration and automation of tasks, like running an antivirus, anti-malware solution, deploying agents like you can see in the screenshot, Chef, Puppet, PowerShell DSC. So anything that's somehow a little piece of software and allows you to run it pretty standalone. I was waiting till it was loaded. Where if you go to your extensions, you selected like the Microsoft anti-malware. I can define some exclusions. This is specifically to configuration of my virtual machine extension, and the deployment is running again. Which brings me to the next important component in VMs, the virtual machine storage. Within Azure Storage terms for VMs, we have two different scenarios, the managed disks and Azure Storage accounts, also known as unmanaged disks. The managed disks are the default option for Azure VMs, and the underlying storage in the physical data center is managed out of the Azure Storage controller, supporting up to 10,000 VM disks per Azure subscription. If you need more, then you have to expand your subscription with an additional one. Using the Azure Storage account approach is obviously the way of working since day one of Azure up till about 3 years ago. Besides supporting virtual disks only in the managed disks, Azure Storage accounts is also giving you some other data solutions if you want out of Azure blobs, files and queues, and giving you 20,000 IOPS per storage account, where the storage account based on the maximum amount of IOPS means that with a 20,000 IOPS you could run a couple of different servers, a couple of different storages, and once you're running out of the IOPS, then you add an additional storage. So it's really that easy. Another storage type that we have, like one level below, is the standard disk or the premium disk. Standard disk is a physical hard drive having 500 IOPS as a maximum and mainly used for like web services, application services, not requiring high performance. Premium disks, on the other side, are only SSD drives giving you 5,000 IOPS. The size of the disks can go up to 64 terabyte maximum, reflecting 80,000 IOPS, and typical target is database servers, file servers, application services, so the more complicated workloads if you want. Another thing that I can talk about for at least a few seconds is that Azure, underlying Azure Storage, in the meantime is extended to 4 terabyte. You can migrate disks, you can interconnect the disks, and maybe even most important, the amount of disks you can add to a machine is depending on the virtual machine size. And what they provided since a couple of weeks is like pushing customers in a certain direction, like this would be for the small system disk, giving you better performance, milliseconds to load, cost saving, and supporting smaller disk, which was valid for their environment. I think I already showed you the virtual machine disk solutioning. Let's check if looks pretty good. What you can do, for example, with disks, if you go to VMs and you select a VM, the one that I just deployed. Next, you go to the disks. It will show you the operating system disk, and you can add an additional data disk here. And again, PowerShell, CLI, ARM template would probably do the exact same thing. 2, something like this. Everything else is okay. SSD drives, an empty disk, and the maximum size, 1 TB. It's doing some background checks, validating if I have the disk space available, if my account is okay, my subscription is fine, and so on and so on. And then confirming, you confirm once more by closing with the Save button. Giving it a little bit of time, and the disk will be added within my virtual machine. From there, obviously, you need to follow the software-based recommendations, like 2 disks would typically end up in a RAID 1, but that's up to you to configure.